In this lesson of sequences and series, we are going to have a look at simultaneous equations. Let's have a look at the knowledge we have on sequences and series. We focused on two different types of patterns. The first one was the arithmetic sequence, and there we have a constant difference. Then we also had a look at the geometric sequence, and here we have a constant ratio. For both of these sequences, we then have a formula for the general term called Tn, and then we added the formulas for the sum of a specific number of terms, Sn. Lastly, we had a look at the sum to infinity, which is not applicable for arithmetic sequences, but for geometric sequence, we have our sum to infinity only if the constant ratio is between -1 and 1. We are now going to use all this knowledge that we have to solve simultaneous equations. In today's examples, the expanded sequence or series will not be given. Instead, you will be given a sentence. That means you will have to change the information given in English into algebra by adding the correct formula and, if given, adding the correct value. Let's have a look at example 1. In an arithmetic sequence, the third term is 13 and the eighth term is 38. Determine the first three terms of the sequence. Now, the first part of information here is that it is an arithmetic sequence, which means we will use formulas that have a d, a constant difference in them. Next part of information is that the third term is 13. Now, the third term is a specific term, so that's T3, and they say the value of that is 13. So now we're going to add the correct formula to this, which is the general term formula. And in this formula, we are going to add our information. So term 3 is a plus 3 minus 1 times d, and we know the value should be 13. So simplified, we have a plus 2d is equal to 13. If we now continue reading, they also say that the eighth term is 38. So once again, they are talking about the specific term number 8, and it has a value of 38. We are again going to substitute the information into the Tn formula, so term 8 will be a plus 8 minus 1d, and we know the value is 38. So we have a plus 7d is equal to 38. Now we need to solve a and we need to solve d to be able to get the first three terms of the sequence. And that we are going to do by using our two equations and solving them simultaneously. In grade 10, you were taught two different methods to solve simultaneous equations, either substitution or elimination. In this case, I prefer to use substitution, so that's what I'm going to do. Now, if you want to substitute, you have to take one of the variables in one of these equations and get it alone on one side. So I'm going to take the first equation and rewrite it as a is 13 minus the 2d. Now that I have a alone, I can go and substitute into the second equation. In my second equation, instead of a, I'm now going to substitute 13 minus 2d. And then it will be plus 7d equals 38. That means I have 5d is equal to 25, and d will then be 5. And now that I know what d's value is, I can go and substitute that back into my first equation. So when I substitute, I will have a is 13 minus 2 times 5, and that means that a is 3. Now that I have a and d, I can give them the first three terms of the sequence. So I'm going to start with my first term, a, and add 5 to get 8, and add 5 again to get 13. Example 2. In a geometric sequence, the sixth term is 8 and the 12th term is 512. Determine the sequence. So once again, our first part of information is that this is a geometric sequence. So this time we're going to focus on formulas that contain an R value, a constant ratio. Next part of information is that term 6 is 8. So that is a specific term. So T6 has a value of 8. Now we're going to add the correct formula to that. So we're going to work with the general formula for a geometric sequence, which is AR to the power of n minus 1. When we now substitute the information that was given, it will be T6 is AR to the power of 6 minus 1, and that value should be 8. Simplified, AR to the power of 5 is 8. Next part of information is that the 12th term is 512, so that will be T12 equals 512. So again, we add the correct formula, which is the Tn formula. So T12 will be A times R to the power of 12 minus 1, and the value should be 512. Simplified, AR to the power of 11 is 512. They ask us to determine the sequence, and for that we need A and R. So we have two equations, and once again we are going to do simultaneous equations. In this case, the variables are being multiplied to each other, and then I prefer to use elimination. So I'm going to say equation 2 divided by equation 1. So I write the two equations underneath each other, and I'm going to divide the left and divide the right. Now, A divided by A is 1. R to the power of 11 divided by R to the power of 5 is R to the power of 6. And 512 divided by 8 is 64. Now to solve R, I'm going to get the 6th root on the right-hand side. You just need to remember that whenever you add an even type of root, your answer will have two options, the positive and the negative. So in this case, R can be plus or minus 2. Now that I have R, I can go and substitute that back into one of my equations to solve A. So now I have two options. R can either be 2 or R can be minus 2. And on the left, when I simplify, I will get 32A is 8. And once I've divided and simplified, A is a quarter. When I substitute on the right, I have minus 32A is equal to 8. And divided and simplified, A is minus a quarter. They asked us for the sequence. So that means two options for the sequence. If I start with a quarter, it means that I have R as 2, which means if I multiply by 2, my next one will be a half, and my third term will be 1. If I, however, start with the first term of minus a quarter, it means my constant ratio is minus 2. So when I now multiply by minus 2, I get a half, and multiplied by minus 2 again, I have minus 1. Example 3. The sum of the first three terms of a geometric series is 52, and the sum of the next three terms is 1404. Determine the first term and the constant ratio of the series. Now, once again, the first thing that is important is that they say it is a geometric series, and this means we are going to focus on formulas that contain a constant ratio. The next part of information is they say the sum of the first three terms. So for sum, we are going to work with an S formula instead of T, the first three terms, and they say that it is 52. So when we add the correct formula, we can now go and substitute. So S of 3 is A R to the power of 3 minus 1 over R minus 1, and that is equal to 52. Next, let's say that the sum of the next three terms is 1404. And now we need to be careful. We cannot again say S3 because it's three terms. They are talking about the next three terms. So in reality, if we want to talk about the sum, it will be the sum of 6 terms, the first 3 and the next 3 together. So that will be the first 3, which had a sum of 52, and the next 3, which is 1404. So the sum of the first 6 terms will then be 1456. And now we add the correct formula. Now we once again have 2 equations, and we need to solve A and R. There are many ways to now go and solve A and R. What I'm going to do is I'm going to try and get one side of these equations to be the same. Now, you will see that both equations have on the left A over R minus 1, and I'm going to try and get that on its own. So for the first equation, I'm going to have to divide on the right by R to the power of 3 minus 1. I'm going to do the same for the second equation. I'm going to get A over R minus 1 alone on the left by dividing by the bracket on the right. Now, because both left-hand sides are now the same, we can accept that the 2 right-hand sides will also be the same. I'm now going to multiply by the bracket R to the power of 6 minus 1 and divide by 52 on both sides. On the left, the numerator can then be factorized. And now I can simplify, so the left will be R to the power of 3 plus 1, and that will equal 28. R to the power of 3 will then be 27, and if I take the cube root, R will be 3. Now that I have R, I can go and substitute that back into any equation to calculate A. If I simplify the left, I will have 13A is equal to 52, which means that A is equal to 4.